Hey, what's going on, guys? In this video we are going to see how to solve this differential equation using Laplace transform. First of all, let's look at the Laplace transform of each of these individually. If we take Laplace transform of x alone, that's going to be equivalent to x of s. Okay, then the Laplace transform of x prime is going to be equivalent to s x of s minus x of 0. And then Laplace transform of cosine t is equivalent to s over s square plus 1. By this time, I hope you guys already learned the table. If you don't know how to transfer cos t, you can look at the table. This is the transform. Here we have cos bt, b is 1, so this is 1 right here, and that's why cos t turns into s over s square plus 1. Now we have x prime cos t, so we are going to write this equation in terms of this Laplace transform. X prime is equal to this whole thing. Let's go ahead and plug this one, and also we have an initial constant x of 0 is equal to 0. This is come with the question. I forgot to write that one. X of 0 is equal to 0. So let's go ahead and plug all the things. X prime is Laplace transform of x prime is this one. So let's go ahead and write that one. S x of s minus x of 0 plus 4 times x is x of s, and then other side of the equation we have s over s square plus s. Here the thing is we have to separate this x of s alone. So if we take the x of s common, we have s and plus 4 right here. And we know that x of 0 is equal to 0. So if we substitute 0, this will go away. So we don't have to worry about this one. And in the other side, we have s over s square plus, actually this one is 1. And then we have s plus 4. Now let's go ahead and write x of s right here and bring this s plus 4 in this side. S over s square plus 1 over s plus 4. Now what we have to do is we have to take the Laplace inverse to get back to this t domain, because we are in the s domain. So to bring that one, we cannot do the Laplace inverse in this way. We have to do the partial fraction decomposition. So let's go ahead and do the partial fraction. The partial fraction of this one is going to be, let's take this one, s over s square plus 4, s square plus 1, s plus 4. If you do the partial fraction, this is going to be just a over s square plus 1. Actually, let's put s plus 4 because s square plus 1 is this is a quadratic formula, so we have to have a linear function. So bs plus c is going to be this one, and s square plus 1 for that. Now we have partial fraction. The next thing is we are going to multiply this whole denominator both sides. This one both sides. So s square plus 1 times s plus 4 both sides. S square plus 1 times s plus 4. If we do that, this side, this one and this denominator cancels each other, so s will remain in the numerator. And in the other side we will have, let's go ahead and write this one, continue this one right here. So s is going to be equivalent to a over s plus 4 cancels, so we will have s square plus 1 in the numerator. A times s square plus 1, and then bs plus c times s plus 4, because the denominator and the numerator cancels, so s plus 4 remains right here. Now we have to pick up a value in such a way we can get rid of this whole thing and solve for a. To do that, we can pick up a value s as negative 4. If you pick up that, this is going to be 0, right? This is going to be 0, and in the other side we will have negative 4. If we substitute s is equal to negative 4, let s is equal to negative 4 is equal to a times s square, negative 4 square, that's going to be 16 plus 1, and in this whole thing will become 0 because minus 4 plus 4, that's going to be 0, and 0 multiplied by this one, that's going to be just 0. So a is going to be just negative 4 over 17, and this is our a value. Now we have a. Then now we have to solve for b and c as well. Okay, let's go ahead and set the equation. We have solved for a, and if we multiply everything, now we are going to compare the coefficient. To do that, we are going to multiply everything. S is equal to a s square plus, I'm multiplying this one, this equation, a s square plus a plus b s square plus 4bs plus cs plus 4c. Now here what we have to do is we have to compare these s square terms and s terms, and then constants. Okay, constants are these two. So let's combine all these terms together, like separate this one. S is equal to a and b has s square, so a plus b s square right here, and 4bs, and 4b and c has s, plus 4b plus c times s, and then a and 4c are constant, so plus a plus 4c. Okay, now in the other side we don't have a square, so that's going to be 0, so we can say a plus b is equal to 0 because in the other side we don't have coefficient in front of a square, so that is 0. And the second one is 4b plus c, that's in front of s we have 1 right here, so 4b plus c is equal to 1. A plus 4c, we don't have any constant in front, so that's also 0. A plus 4c is equal to 0, and here we already know the a, so we can solve for c right here. We already know a, we can solve for c. Now a is negative 4 over 17 plus 4c is equal to 0, therefore 4c is equal to 4 over 17, therefore c is equal to 1 over 17. Now we have solved c, we have solved a. The next thing is we are going to solve next thing is we are going to solve, we solved a, we solved c. Next thing is we are going to solve b. Okay, to solve b we can use this equation because we already know a. A plus b is equal to 0. A is negative 4 over 17 plus b is equal to 0, therefore b is equal to 4 over 17. Okay, that's it. We have found out a, b and c. Now that's it, and now we can go ahead and plug it in this equation. Let's get rid of some of these things. Okay, let me bring this layout and let's get rid of these things. And here I'm going to use a completely different color. Okay, here we have found out a, b, c. Now we have to plug it in this one. Okay, a is equal to negative 4 over 17, so negative 4 over 17, and that is equivalent, that times 1 over s plus 4, and plus bs. B is 4 over 17, 4 over 17 s, plus c is 1 over 17, 1 over 17, and over s square plus 1. Okay, now y of s is equal to this. Now we have to find out y of t. actually x of s is this. To find out x of t, we have to take the Laplace inverse. So x of t is equal to Laplace inverse of minus 4 over 17 s plus 4, 1 over s plus 4. This is going to be just e power negative 4t, because if we have s minus a, that's e power at. Here s minus 4, so e power minus 4t, plus here we can separate this one into two things. So first 4 over 17 s over s square plus 1 plus 1 over 17 1 over s square plus 1. Okay, for these two we have to take the Laplace. Okay, you know what, I have Laplace inverse sign, so I cannot do the Laplace here. I do this in next step all together. Okay, in the next one we are going to do it all together. So I keep the previous one as it is, 1 over s plus 4. In front of this one we have minus 4 over 17 multiplies. Okay, now let's get rid of this one. Okay, now let's go ahead and take the Laplace inverse of whole thing. X of t is going to be equivalent to Laplace inverse of this, that's minus 4 over 17 e power negative 4t, and here we have 4 over 17 cos bt. B is 1 right here, so this is going to be just cos t, and plus 1 over 17. Since we have b over s square plus b, this is going to be just sine bt, so sine b is 1, so this is going to be just sine t. Okay, and that's it. This is our general solution of this differential equation. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn differential equations, there are a bunch of videos in my playlist. I hope you guys watch it too, and don't forget to subscribe. See you next time.